Welcome to Sage Audio. Today we're doing an EQ Masterclass. But first, if you have a mix that you need mastered, send it to us at sageaudio.com to receive a free mastered sample of it. Parametric EQ. Let's start by covering the EQ you're most likely going to use, a parametric EQ. With this one in particular, you can choose from 9 different filters. These are bell, low shelf, high pass, high shelf, low pass, notch, band pass, tilt shelf, and flat tilt. The slope of these bands is measured in dB per octave, and the Q value can typically be made proportional to the amplitude of the band, so you can notice how the Q changes as I increase the amplitude of the band. Various parametric EQs will have different features, be it analyzers, EQ matching, mid-side imaging, and more. Now, I'd show you a parametric EQ, but it's more or less a parametric EQ just with a missing function. Additionally, sometimes an EQ has both parametric bands and semi-parametric bands. For example, the Weiss EQ1 is parametric, but the high-pass filter is just about semi-parametric since I can barely control the slope. Additionally, I'd show you a shelving EQ, but as we covered, shelves can be created using parametric EQs. So I want to spend more time on info I think will be of real value to you. Let's listen to the FabFilter EQ first, using various filters and Q values. Natural sounding EQ versus digital. Now that we understand some of the features of a parametric EQ, let's cover how we can use them to achieve either natural or unnatural sounds when affecting our signal. Let's start with the natural phase response, which will closely emulate the phase and magnitude of analog equipment. Then let's enable proportional Q and stick with 12 dB per octave or less. The lower our Q value, the more natural the sound. For a digital sound, let's use a low latency linear phase, which I'll cover more in a later section. Then we can use higher slopes and Q values to make our EQ more surgical. This may sound aggressive, but it's helpful when you're trying to pinpoint frequencies. Let's listen to these different settings. If you're enjoying the video, consider hitting the like button. It really helps us out. Should I use linear phase EQ? Linear phase EQ is best used to solve specific problems. For example, if you have a parallel signal that you're equalizing, but the original isn't being filtered, use low latency linear phase to avoid phase cancellation. Also, if you're using high pass filters, it can be helpful there as well. At high settings, it can cause a pre-ringing effect, but in my opinion, concerns about this are often exaggerated. Personally, I stick to zero latency, natural phase, or low latency phase modes. I find low latency to be great when I want as accurate of equalization as possible without affecting my transients. Let's take a listen to these different modes. Graphic EQ. Odds are you're not going to use a graphic EQ in many circumstances, but let's cover them regardless. With them, you can easily visualize the curve you're making. You typically get fixed bands, but some digital models and emulations allow for adjustable center frequencies, as well as some distortion features. For example, Logic stock graphic EQ, which emulates an API, lets you introduce harmonic distortion. Foxingo's overtone GEQ also introduces harmonics, but without the ability to control them. Whether or not you use a graphic EQ will probably come down to preference, since there's no real advantage to using one over a parametric or semi-parametric EQ. Let's listen to the two graphic EQs that we just covered. Equalizing with a compressor. Next, let's talk about some more obscure topics that are important nonetheless, like how compressors can be used for equalization in many ways. The main way is with the attack and release function. For example, let's say we're compressing a strummed acoustic guitar track. With a quick attack and long release, we're going to attenuate that initial transient of the guitar. That transient, as you know, has a frequency and amplitude, and when we attenuate it, we ultimately change the guitar's frequency response. With the long release, we're also going to affect other transients and content in the signal, again, reducing the frequency of the percussive elements of the guitar. Then, we have to consider how a short attack will distort the signal, adding harmonics, which will also affect the guitar's frequency response. So in short, a lot more effects are equalizing your signal than you may think. Let's take a listen to these compressor settings and pay particular attention to the high frequency range. Only a small percentage of the people that watch our videos are subscribed, so if you're enjoying the video, consider subscribing. It's free and you can always change your mind. Equalizing with a saturator. The effect a saturator has on the frequency response is a lot more noticeable than a compressor. Let's run a sine wave through a saturator and observe all of the additional content that it creates. As you can imagine, all of these harmonics have a huge effect on the frequency response. If we want, we can measure the response of soft tube saturator knob with an analyzer and see just how drastically it can shift the frequency. So it doesn't matter if you're making these shifts with an EQ or if another processor type is causing them, the changes are happening nonetheless. Keep this in mind when you're using various processors. Let's listen to this saturator and pay particular attention to how the frequency changes. Dynamic EQ or multiband compression. Dynamic EQ is another important equalizer to be familiar with, but it's often compared to a multiband compressor. So let's look at the two and see what the main differences are. A dynamic EQ offers more control over the band with more Q and slope values. Also, it often offers more available bands. For example, the Pro Q3 can have 26 dynamic bands, whereas the Pro MB offers 6. But it lacks some of the traditional dynamic processing elements you'd expect in a compressor. You mainly get a threshold that's either manual or automatic, and that's about it. Conversely, the Pro MB offers attack and release controls, look ahead, knee, and other functions more closely associated with compressors. So ultimately, what it comes down to is how much control do you want over your dynamics processing? Do you prioritize pinpoint control over the frequency or more control over the compression elements? If you care more about the first, use dynamic equalization. If you care more about the latter, use multiband compression. Let's listen to both. If you'd like our custom plugin presets, samples, loops, session tracks, MIDI packs, and download sheets, join and become a member And if you change your mind, you can cancel anytime. Advanced Mid-Side EQ. Last up, let's talk about mid-side equalization, which is great for combining equalization with stereo imaging. Let's cover some more advanced topics about it. Specifically, I want to show how you can dynamically alter your frequency response and image based on an external source. So, say I was mixing a vocal and an instrumental, and I wanted the instrumental to have specific frequencies dip whenever the vocal was sung. For my external sidechain, I'd insert the vocal. Then I'd create multiple bands and center the bands on the frequencies I want to cut. Then I'd make these bands dynamic. If I select the band and go into the dynamic settings, I can click on an external sidechain icon, which now makes the band's threshold measure the external signal, or in this case the vocal, rather than the instrumental. So now my bands are dynamically responding to the vocal. If I want to take this a step further, I'll change the stereo placement of my bands. For example, I can make one band attenuate the mids and another the sides. Now, I know this is a specific example, but I like it because it covers almost everything that we've talked about so far. We have our parametric EQ, we're affecting our Qs and slopes, we're using dynamic equalization and mid-side equalization. Furthermore, we can use linear phase equalization if desired. Let's take a listen to it.
Please don't tell me that you're sad and you didn't miss all the moments that we live and you don't care. You don't miss nothing, you don't miss nothing, Please don't tell me that you're sad cause you don't care. Tell it somebody else.
If you have a mix that you need mastered, send it to us at sageaudio.com to receive a free mastered sample of it. Also, join and become a member for exclusive advanced videos, future plugin presets, samples, MIDI packs, and more. Thank you so much for watching.